right, so in this video, we're going to look at our last unit in Math 12, which is something called limits. So we're going to look at this thing called a limit and what it is. Now, the issue with limits is at first, after you see the concept of it, be like, well, okay, well, why does somebody want to do this? The thing to keep in mind is that, remember, this is a pre-calculus course. Limits are important in calculus. So if someone goes on to take calculus, and for seniors, if you go on in math, that might be the next course you would take. If you're an honors junior, a lot of people are going on to AP calculus, and then you would obviously need to know this for that. So keep in mind that I'm going to show you this limit concept and bear with it. It does have a use, but you need to learn a little bit of calculus to then see how the limit gets used. Because actually, historically, these were developed kind of backwards. Like people came up with calculus, and then there was kind of problems with calculus, and they came up with this limit concept as a way to make sure they could prove everything and fix everything and put everything on a solid ground. So realize, unfortunately, we kind of teach it the other way. We learn what the limit is, and then we see how it's used in calculus as opposed to the way it was actually developed. So at first, it may seem like, well, why would someone want to do this? If you take calculus, you'll see why somebody would want to do this. If not, just bear with it. It's something that I'm going to show you how to do it in a calculator. So even if you're not going on, it's something you should be able to at least calculate, and it's not hopefully that big of a deal. All right. So now that I've done the preliminary of why would somebody want to know this, bear with me and just see how it works. So it's something called a limit. And basically in this goal, I want you to be able to know what the concept of a limit is. So sort of start to get the idea, and it might take a few lessons to really get what's going on. But we'll try to get it on, get you understanding it at least early, at least roughly what's happening. So we want you to know the concept of a limit and then how to approximate one. There are ways to find them exactly. That's a little more advanced. So we're just going to use something called a table to approximate a limit if it exists. Like I said, using this table method. So the thing with a limit is that it's either going to have a numerical answer, or it may not have an answer at all. It may just not be findable. So I'm going to show you how to get the number that's the answer, or we'll talk about a little bit now if it doesn't exist, and then more detail later if, how you can even know if there's an answer. So basically, your answer is going to be a number unless for some reason you can't find the number. So let's talk about the concept so you know what I'm even talking about. So what is a limit? Has to do with functions, right? Which most of high school, that's pretty much what high school is all about, right? Learning about functions. As you know, hopefully from a function, I've been doing them probably since late middle school, definitely since beginning of high school. Algebra is all about functions. A function has an input and an output. In fact, a function, you have an input and then there's only one output for that input. So as you put inputs in, you get out different outputs. What the limit wants to know is what is happening to those outputs. So what's happening to the y values if you start to get close to an x value, right? So you could pick any x value, something like an x value of 2. And then what the limit is asking is, as you get closer and closer and closer to 2, what's happening to the y values? And now there's some pretty strange examples of functions. So I'm not going to show the pictures yet. I may do that in the next lesson, because I want you to get a feel for what are you doing with the numbers and what are you looking for. And then I could show you some of the sort of the ways the limit works on the functions, telling you about how they look. The big thing with a limit is to think of it sort of as a function microscope. So what you're doing is you're going to close in on an x value. You're going to get really, really, really close to the value. Now, you're not actually going to get to the value, but you're going to get super, super close to it. So they're going to tell you an x value. I said they may pick 2. You're going to pick numbers really, really, really close to 2. And I mean like really close, like you're going to get, little decimals. You're going to get super close to 2, and you're going to look at those numbers and see what their y values are. You can do this pretty easily with a calculator. It's hard to plug in, like if you want to get close to 2, like a number that's really close to 2 is like 1.99999 or something. You can figure out what the function value is for that. So as you pick something really close to 2, what's its output? It's easy to get a calculator to tell you some of these because they're kind of hard to get by hand. All right, but the first thing when you're doing these is you have to realize that you're going to get close to an x value, like really close. Sort of zooming in on the number line. You get super close, and you're going to say, what's happening to the y values? Now, there's kind of two different things that can happen. As you get close to an x value, usually the function will get close to a y value. So as you approach an x, the y values want to approach something. If that happens, you have an answer. So that's what it says down here. It says, as you get close to an x value, if the y values, it says the y values might get close to something. If the y values get close to something, that's your answer. If there is no answer, that's what I put here, we say DNE if the thing doesn't exist. So if for some reason you're not getting close to some y value, like say you get close to an x value like 2 and the y values are doing something strange, then we'll say it doesn't exist. There's different examples of these things. For now, I'm going to keep it simple and basically I'm going to look at ones that have a limit, have a y value you get close to. But I'll show you one at the end where the y values don't get close to something, and we would say DNE if it does not exist. All right. So if you get close to something, that's your answer. If we don't get close to something, we say DNE. And once again, to be specific, we're getting close to an x value. We want to see if there's a y value we're also getting close to. All right, and I'll show you that in a little bit. So for the DNE part, realize that the y values, if they're not going to get close to other things, what's some weird stuff you could see? The y values don't have to close in on a number. They may get super big. They may start becoming like infinitely large. Later, I'll show you a function where they kind of randomly bounce around, so the y values go up and down, back and forth, back and forth. They don't ever really go toward anything. Or sometimes there may not be y values at all. Sometimes there's no function there. You're trying to find a limit. You go, well, there's no y values anyway. In all those cases, the limit doesn't exist. So there's this very specific case where we're seeing, do the y values approach something? If they approach something, we have an answer. If they don't approach something because they're getting really big or they're bouncing around or they're not even there or any other crazy case, then we would say that it has no answer, but we would use this term. You would say, well, it's DNE, aka it does not exist. There's no answer I can give you. All right. So now I'll show you how to calculate when using a table, because like I said, this is just kind of the concept. I've been talking about, well, we get close to an x, we look at what's happening to y, and it helps to see an example of what's going on. So the first thing I have to talk about is we're going to make a table of values. We're going to use the calculator to make it easier because we're going to use some decimal numbers and they're hard to calculate. So the calculator part's pretty easy, but the hard part is what numbers are you supposed to pick? So what we're going to do is, remember, we're going to get closer and closer to an x value. So we have to start picking numbers that are really close to an x value. So the technique is actually to pick one that's kind of close, then pick one that's closer, then pick another one that's even closer. And you do this, usually I'm going to show 3 times. You get closer 3 times. You can go even further. You could do it 4 times, 5 times. You keep getting closer. You can actually get infinitely close if you wanted to. There's always another number you could get a little closer to. But usually you don't have to do, you don't have to do 7 or 12 of them. Usually if you do 3 of them, it's enough. But I'm going to show you how to get closer to the x values. Then what I'll show you is after I show how we're going to pick our x values, then I'll show you, well, here are the y values and how we can read what's happening with them. All right? So hopefully this will all start coming together in a minute because I've been trying to be very general here. So let's look at an actual example and see what's happening. All right? So to look at example, we need to know how they write stuff. Like math is all about notation. So if we're going to have a notation for the limit, we should tell you what it looks like, right? So how did people decide to write the limit? This is the general version of how someone writes a limit. So they abbreviate limit with lim. It's kind of like when you do logarithms, right? People don't write logarithm, they write log. So, log base, whatever. So the lim is a little shortcut for limit. So someone writes lim, so you know, oh, I'm taking a limit. Now, remember I said x value, you approach an x value, and then you look to see if there's a y value you also approach. So there's 3 components to the limit. On the left side, you'll see x approaches something. This will be the number. So whatever number they want you to approach, they'll put it here. So if they want you to approach 2, they'll put the number 2 right here. You're going to approach the x value, but you need a function to approach. You need some kind of, like a parabola or a sine curve or whatever it is. So the function goes here. So it's abbreviated for, with f of x, but they'll actually write the function here if you know what it is. So normally what you see is that left side, there'll be some number you're approaching on some, x value you're approaching on some function. Now, if it has an answer, that's what this capital L represents. The answer to the limit would be if you see as you approach the x value, there's some y value that you also approach, that's your answer. You put that number out here as your answer. If you're not approaching anything, if you think for some reason the limit doesn't exist, where the equal sign is, you can just put the abbreviation DNE. That tells someone, what is this limit? Oh, well, you're asking me a bad question. There is no value to the limit, all right? So there's one or two things that go here. It's either a number or doesn't exist, and you're going to put DNE. There's actually one other case. Sometimes if a limit's infinite, they may not put DNE. They might just put infinity, but infinity is not actually a number. So I'll get into that detail later. But for now, we're going to put either a number or we're going to put DNE. So either we're approaching something or the function's weird and we're not approaching something. We'll look at an example or two where we approach something, and then at the end I'll show you here's one where it wouldn't exist, so you can kind of get a taste for that. And then subsequent lessons will just go into this concept more deeply. Hopefully people get the hang of it. All right. So in the example, there's going to be a number here, a function here, and we're going to be trying to determine this value. So now that I've talked about the notation, once again, I said, how do we approach a number? How are we going to get closer and closer and closer to whatever this number is? So here's how we do it. All right. So I'm going to look at this example. So we want to calculate what's the limit as x goes toward 3. So the way you read this is the limit as x approaches 3 of x squared minus 3x plus 4. What does this equal if it equals anything? So what this is asking me is, as I get closer and closer and closer to 3, what does this function do? So the question is, how do you get closer and closer and closer to 3? Well, you have to think of zooming in on the number line. So what I have here is I have 3, and then I'm going to look at things to the left of 3 and try to get close to it. So here's something to the left of 3 all the way over here. Here's 2, right? On a normal number line, you'd go 1, 2, 3, and you'd just go from 2 to 3. But there's lots of numbers in between 2 and 3, right? There's 2, there's 2.1, there's 2.5. We want to be close to 3, and we want to get closer as we go along. So you can really pick any numbers to get closer, but the technique to make it simple, that way you're not just picking random numbers, is to sort of follow a pattern. So what you do is the first number you pick isn't this number, it's not that close. You usually go pretty close by going like 1 decimal place off, right? This is 1/10 away. So you start by saying, I'm going to get kind of close to 3, right? This is pretty close. 2.9 is not that far from 3. So you start with 2.9. And then you go, well, I want to get closer than 2.9. The easiest way to get closer is just to throw another 9 on it. So then you go, well, I'll try out 2.9. Then I'll try out 2.99 because that's even closer. And what's even closer than this is 2.999. Now, for most of my examples, I'm going to use 3 of these. Now, you could keep going. There's more numbers closer. You could do 2.9999, or you could do 2.99999999999, right? So you can keep getting closer and closer and closer. You usually don't have to do too many of them. I said, I'm going to use the standard of 3. If I need to do a 4th one, I'll do it. But most of the time, once you see 3 of them, and the reason you want to do a few of them is you want to see a pattern that's appearing. What I'll show you later is that if you only do one of them, you might get the wrong idea. You might think, oh, I did one of them, and it's getting I see what this number is plugged into the function. But what you want to do is see a pattern of them. You want to try a few of them out, make sure that the y values are also following the same, sort of a similar pattern, they're approaching something. But anyway, on the left side of 3, I could use 2.9, that's close. Closer is 2.99, even closer is 2.999. So now that's close on the left side. There's the other side of 3, right? There's being close on the right side. So how do I get close on the right side? Well, I showed that as well. Here's 3, and remember, if it was a regular number line, we'd go 3, 4, 5, right? But we want to get close to 3 on the other side as well. So when you do a limit, you got to look at both sides. You got to look at what's happening on the left and what's happening on the right. So how do I get close to 3 on the right? It's a little different than how I get close to it on the left, because on the left, I just kept adding 9s to it. On the right side, well, what's close to 3? Well, 3.9 is actually not that close. What's close is to be like a 10th off. 3.1 is pretty close, right? So we could start with 3.1, and then we could keep throwing zeros on it. 3.01 is even closer. 3.001 is even closer. If I want to get even closer, I could do 3.0001 or 3.00000001, right? So once again, we don't have to do too many of them, but we have to do a few. So hopefully this shows like when I go to do this table method, because I said I haven't even answered what this limit is yet because I have to set all this up. But when I go to get what this limit is, I'm going to use these numbers. I'm going to start making a table and go, I'm going to try this and this and this as they get close to 3 on the left. I'm going to try this and this and this because they get close to 3 on the right and see if there's a pattern. Then I'd look at their y values, all right? Before I go on, let's see getting close to a couple other values. So like this is the limit as I approach 3. What if I was doing the same function but wanted to approach -2? Be careful with negative numbers. So now I'm setting it up a little more like you'll see me do in the tables. Since I know that I have to get closer on the left and closer on the right, usually what we do is we'll put the number we're trying to get close to in the middle, and then we'll use the numbers on the numbers on the right should be getting closer, and the numbers on the left should be getting closer. They're sort of zooming in on that value. Now, be careful with negative numbers because the number line's backwards, right? What's to the left of -2? Well, -3 isn't over here. -3 is over here. So you got to be careful that negative numbers are backwards. You got -3 to the left and -1 to the right. So when you're doing those, getting closer and closer and closer values, they're kind of reversed from before. From the left side, what's close to -2? Well, -2.1, -2.01, -2.001. What's getting close on the right side? Well, -1.9, -1.99, -1.999. So notice that each time I pick a new number, it's closer to -2 than the one before it. And it's kind of easy to pick these numbers because I say you can keep adding 9s, you can keep adding zeros, and it's homing in on this. Once again, I could go further. I could go to -1.9999 or -2.0001. But usually 3 is enough. So these are the 3 values I could use to approach this. Now, once again, I still haven't calculated the y values, but what we would do is look at the y values of these to answer this question. The last one I want to show getting close to is 0. And I hope if I put the 0 here, I think I copied this and forgot to change the number. So say you want to get close to 0. Be careful with 0 because there are no 9999s with 0, right? If you're getting close to 0, 0 is the borderline between positive and negative. So if you want to get close to 0 from the right, you'd use 0.1, 0.01, 0.001. If you want to get close from the left, this is kind of a weird example because it's the mirror image. It's -0.1, -0.01, -0.001. So be careful when you're picking your numbers because if you made this side correct, but then you put 0.9, 0.99, 0.999, like 9s aren't getting close to 0. 0.99999 is getting close to 1. So be careful that you pick your numbers correctly. These cover the 3 scenarios, right? Like if you're going near a positive number, you'll do the 9s on the left, the 0s on the right. If you're going toward a negative number, they're reversed. With a negative number, the 0s are on the left, the 9s are on the right. And then if you're actually going towards 0 itself, you have to be careful that it's 0s on the right and 0s on the left because 0 is the borderline between positive and negative, so you don't want any 9s in it. The 9s aren't getting close to 0. They're getting close to a different number. All right, so finally, now that all this is set up, because I said I've been here 19 minutes, now hopefully it's quick to show how to actually calculate one of these limits. But I said I had to set all this up because this is how we're going to set up these tables. So now how do you get the answers to these things? Well, let's look at this example. So I'm going to approach 1. All right, so finally, same function. I showed you different numbers. Let's find, well, what is the limit as I approach the x value of 1 for this function. So here's how you set up the table to answer it. So you're going to pick x values that get closer to 1. x are the values that get closer to 1, and then you're going to look at the y values. F of x are the y's, right, the outputs. So I'm going to put the inputs and see what's happening with the outputs. So first you have to set up your inputs. What gets closer to 1? So this is why I just spent the last 10 minutes trying to show you. Well, here's how you can set up the table. Put the value you want to approach in the middle, which is the value 1. On the right side, get closer and closer and closer to 1, and on the left side, get closer and closer and closer to 1. On the left side, I'll use 0.9, 0.99, 0.999. On the right side, I use 1.1, 1.01, 1.001. These numbers are getting progressively closer to 1. Now, I don't actually care what's happening at 1. What's weird about these tables is you don't need to find this value. Sometimes this value will be the limit, sometimes it won't be. So you need to be very careful, right? Don't necessarily put this number in the calculator. We don't care what happens at 1. The limit doesn't care about the actual value itself. So we're not finding f of 1. We just want to see what's happening to the y values, all right, as we get close. So here's what you do in the calculator to get, I want the y values for all these. Now, if I had to do this by hand, I'd have to go back and plug them into this function, which is really annoying. So I'd have to plug them into the y value here, into this function, and find the y values. Now, I don't want to do that by hand because that's annoying. So I'm going to start plugging them in. Here's an easy way to do it in the calculator. So what you do is you plug in your function. So you hit the y equals, and I'll show you in a second. Let me scroll back up and get the function so I know what I'm putting in. I'm putting in x squared minus 3x plus 4. All right, so what you do is you go to the y equals, and you enter in your function. All right. If you don't have a graphing calculator, you can find online graphing calculators. Maybe I'll put one in the link. But like I said, there's ways to put these in and get a table of values for them. So anyway, if you have a graphing calculator, you pop it in there and you go, well, there's my function. So now you want to plug in these special values. You want to get these numbers. So what you do is you hit second and the window button. It's a little hard to do this with one hand, but second and window. Up above it, it says table set. So when you go to table set, you'll see this screen. Now where the cursor's flashing, where it says independent, is what it's supposed to say, it's the independent variable, that's the x variable. You don't want it on auto. You want to move it over to ask and hit the enter button. So what this is going to do is once you hit enter and clear out of this, you're going to be able to actually put in your own values for the table, all right? So what you can do from here is once you do that, I'm going to go to the table. So I'm going to hit second and the graph button. So remember, that's how you get to the table. So once that's on ask, hit second and the graph button, and you'll see a table. I can get this to, now it's graphing something. Come on. There we go. So what you'll see is something cleared out. I think I already entered them in is my problem. So I'll see if I can. All right. I'm just going to put in some values. So I just put in a bunch of zeros here. So what you can do on this screen is enter in, because I already entered them in, so they were here, and I wasn't able to delete them out. So you'll see nothing here if you've never done this before. This will be blank. What you can enter, though, is these numbers. So you can put in your own numbers. So I'm going to put in that 0.9 first. When I put in the 0.9, it gives me the y value. 0.9 pumps out 2.11. Then I'll put in 0.99. When I put in 0.99, that pumps out 2.0101, and it probably keeps repeating, but it doesn't show that much of it. Now I'll put in 0.999. All right? And then that comes out as 2.001. Now I could put in 0.9999999 or whatever, but I'm just going to use these three and stop there. Now on the other side, I can put in these values as well. So I'm going to enter them. And then show you what I got. So here's the other side. So I entered these. on the other side. So notice that if you kind of read, the numbers as they go up are getting closer to 1, and the numbers as they go down are getting closer to 1. These are all the y values I want to enter. So those start going down here. I can put in what I got for 0.9, 0.999, and so on. So I actually have that below. So this is the goal. The goal, finally, is this x value. If you pick numbers approaching the x value, see what's happening with these y values. Well, now you have to be able to be good at reading these numbers. This number is 2.11. This number is 2.0101. This number is 2.001. I'm trying to see, are these y values getting closer to some number? Well, these look like they're getting closer to the number 2, right? 2.11's kind of, it's close to 2, but we could get closer. 2.0101's pretty close to 2. 2.001's even closer. In fact, if I wanted to see more of them, if I put more 9s on this, this would actually get closer to 2. It would have more zeros. The other side does the same thing. So 1.1 gives me 1.91. Then I get 1.9901, and then 1.999. And if I wanted to do more, I'd see, well, once again, these numbers are approaching 2. So then what's my answer? Well, I had these approach 1 and these approach 1. What are the y values doing? That's the whole thing the limit asks, right? So the limit goes, if you approach 1, what do your y values approach? Well, your y values approach 2. It's what it looks like. Now, you don't know exactly that it is. Maybe it's approaching, 1.9999999 or something, or slightly off. But you give your best guess. So our best guess is, this looks like it's approaching 2, right? Or it's getting pretty darn close to it. So then when you go to answer this, and I don't have my smartboard, so I can't really write on it like I'd like to, but if I wanted to give the answer to this, after doing all that work, I go, okay, well, equals 2, right? That would be my answer. All right, so this doesn't quite take as long. It takes a while to explain, but once you know how to do it, it really doesn't take that long with the calculator. So let me show you 2 more examples. Hopefully now that you've suffered through 25 minutes of explanation, hopefully now I can go faster. So this I would enter into the calculator. So now they're asking me here, what's the limit as x approaches 3 of this function? So remember what you would do, just to show it again, would be you would enter that function. So I'm going to enter that and then show you what I entered. So you go to the y equals, you enter this function. So give me a second. There we go. All right, so I went into y equals, there's the function, right? Then what you do is, now since I already did the table set thing, once you set it to ask, if you want to put it back to normal, you have to put it to auto. So I would say if you're not doing limits, make sure you set that back. But so once it's on ask, you don't have to do it anymore. You can just leave it there and then just go straight to the table. So once you go to the table, it'll start giving you what values you approach as you put this function in. All right. So when I start putting this function in, I got these values. And some calculators give you decimals. Some might give you the fractions. Just try to find what those fractions are. And if you don't have the fancy calculator or fancy table, it's longer to do, but you could just put this number in. You could put in 2.9 minus 4 times 2.9 minus 3 over 2.9 and do it, kind of by hand. But it's easier if you have the calculator ability and you're able to go to a table. And like I said, even online graphing utilities will do this for you. You can enter the value that you want. So after putting this in, these numbers look like, so I want to see what the y values are approaching, right? So as I approach 3, what are the y values approaching? Well, the y values in this case look like they're approaching -1, right? So I have -1.1, -1.01, -1.001. And then these also are going close to -1. -0.9, -0.99, -0.999999. They're getting close to -1 as well. So when I see this, that look, these are getting close to -1, that's my answer. This equals -1. Now, one thing about trying to kind of cheat with a shortcut, because let me show you the difference between these 2 examples. In this example, some people, if you're a little extra clever, you might go, well, why am I doing this limit stuff? Why am I doing all these decimals? What if I just plugged 1 in, right? So say I took this function and just plugged 1 into it. You might go, well, let me just put the 1 in and see what happens. On this function, so I'm going to put it back in the calculator, you'll see that this function actually just pumps out the limit answer. So there's my function. If I just wanted to see, I'm going to put the normal table back on. If I just wanted to see what happened to 2, so here's the normal table with all the weird decimals, I could go to 1 and go, oh, well, the y value's 2. So why did I do all this work to find out it was 2 when I could have just plugged this in, right? But I said the limit doesn't really care what happens when we plug it in. It just wants to see the approach. Sometimes you can plug this in and it'll give you the limit. But here's the problem. It doesn't always work. This is why I'm not showing you to just plug this in. That's why it's better to look at these values. The next example will show that, because if you try it on this example, so once again, I'm going to have to plug it in. I'm going to plug this in and look at what happens at 3, and you'll see that it won't give you -1. Like, it should give you -1. You'd think, oh, well, won't this give me the limit answer? But let me show you what happens. So it's going to take me another second to enter all this back in. Let's see, so we have x minus 4, x minus 3, and all over x minus 3. All right, so I got that function back in. So now I'm going to show you, well, what happens if I just plug in 3? I think I'm going to shortcut it, right? And I'll show somebody. Notice that if you try to just shortcut this one, it gives you an error. So if you go, oh, what happens at 3? Well, 3 is undefined. It actually doesn't have a value. The problem is when you try to plug 3 into this, this bottom comes out as 0, and you're not allowed to divide by 0. So you have to be careful. In the calculator, this comes up as undefined. It's an error. But notice it still has a limit. And this is actually part of the reason why the limit concept exists, because if you can't know what the function value is, you can at least know what the function value is approaching. So even though 3 doesn't actually have any answer, we would still say, what's the limit as we go toward 3? What happens as we approach 3 is these y values want to go toward -1. So this is still equal to -1, even though if we get to 3, there is no answer. So in these examples, don't just plug in this number. This doesn't always work. Sometimes it works, sometimes it doesn't. If you want to learn more, you can find out like why it works sometimes, why it doesn't work other times. But for now, when I see, when you try to do it, try to do this approach thing. And like I said, you can't cheat it. Sometimes you can. Like I said, this function, you could cheat by plugging that in and seeing what it is, but it doesn't always work. On this function, you can't just plug this in and cheat. You have to do the approach to see what's happening. All right, let's look at one last one and then hopefully get this over with. Because like I said, this is getting kind of long. I didn't want it to be this long, but I have no choice. It'll be the only one for the week. That's the good news. All right, so here's the last one I'll show, because I want to show one where it doesn't exist, right, where it doesn't happen. So in this case, they want us to have the limit as we approach 0 of this function 1 over x. So what happens is I approach 0. Once again, I think I copied this wrong, so let me get this to be the right number. All right, so I want to approach 0, so I put the 0 here. And I said I kind of have, not everyone puts this. I kind of put the double lines. That way someone knows that's what I'm approaching. Sometimes if you look at books, not everybody does this, but whatever. I'm just showing, here's what I want to approach. So like I showed you earlier, make sure you pick the right numbers. How do you get close to 0? Well, you pick 0.1, 0.01, 0.001. That's getting close from the right. Be careful when you get close to the left. It's -0.1, -0.01, -0.001. These numbers are... Each one of these is closer to 0 than the one before it. Each of these is closer to 0 than the one before it. So now you could go to the table. You could plug this in. And I said maybe might as well show that too. I'm going to plug in 1 over x. So let me get that in here. So you would go to your y equals. You put in your function. There's mine. Look, it's 1 over x. I don't have to go to the table set if I've already set it to that ask. It'll ask me what I want to put in. I would just have to put them in. So let me show you. If I go to ask, I can just put in what I want. So you put the right numbers in here. -0.1, -0.01, 0.001. So I'm not showing both sides here, but I'll just show a couple. So there, notice I just plugged them in. The calculator pumped out the answers. That's where I'm getting these from. So when I plug this in, I get negative 10. Then I get a negative 100, and I get negative 1,000. Notice that the y values aren't approaching a number. They're not getting closer to a number because you're 10, then you're negative 10, then you're negative 100, then you're negative 1,000. The next one would be even more negatively large, if you will. It'll be a number that's lower than these by a lot. Same thing on the right side, right? It's actually not the same thing because these are negative. But on the right side, it's 10, it's 100, it's 1,000. So this is a case of you have to be careful because sometimes people see this and go, oh, it's approaching 1,000. But it's not. You have to think what's happening as you get closer and closer. Well, it's 10, it's 100, it's 1,000. What if I went to the next one? So I just threw in one more because, like I said, I've been doing 3 of them. But now I did a 4th one. What if I did 0.0001? Well, that comes out as 10,000. What if I do 0.00001? Well, then I get 100,000. Notice that the closer I get to 0, the bigger this gets. This number keeps getting bigger and bigger and bigger, and it won't stop getting bigger. These are not approaching a number. This number is growing without bound. It's growing like crazy. This is going to become positively infinite. And this one's becoming negatively infinite. So this is a case of where the limit doesn't exist because these don't approach a number, right? They're not getting close. It's not like, oh, it's getting closer to 7 or something. They're just getting larger, and then these are getting negatively larger. Not only don't they agree, they're not going toward the same number. So this is becoming positive, it's becoming negative, but they're becoming larger as you go along. So that's why I have that little arrow there. Go, hey, if we did another one, it would get even larger. If we did another one, remember, you could keep getting closer. I've only been doing 3 of them, but here's the 4th one. So this would be an example of what does this limit equal? We would say DNE. It doesn't exist because it has this weird behavior. All right. So to end this, hopefully you kind of realize what's happening, how to read this, how to get close to the value 1, and then take the values that are close, put it in here, and see what's happening with the y values. In this case, I can get back to the bottom. As I went close to 1, the y values were getting close to 2, so that's my answer. In this one, what happens is I got close to 3 for this thing. Well, as I got close to 3, these were going close to negative 1. And then this last one, what happens with this thing as I get close to 0? Well, as I closed in on 0, this side gets infinitely big, and this side gets negative infinite, goes toward negative infinity, however I want to say it. So this one isn't going toward a number. It's going toward hugeness, and that just means DNE. It's not flattening out toward a number. All right. Well, this took a while, but basically, if you can get this concept, most of the rest of the videos are just looking more deeply into doing this. That way you have sort of an intuition for this process. And once again, the reason for this process is there's something in calculus that requires this concept. So it's a little hard to show you what it is without some calculus. But like I said, if you're someone who goes on to take it, you'll see, oh yeah, this was important for something. All right, for now, this has been way long enough. So like I said, this will be the only video this week. Basically, your homework assignment will be, it's going to be close to these examples. It's going to be trying to find some limits. One, I think there's 3 problems kind of like this. 2 of them come out as numbers, and then one of them comes out, a little crazy like this one. It'll be a similar problem. So hopefully you can approach put the number in the middle, put these numbers approaching it, throw them into a calculator, get the y values, and try to figure out what's happening with the y values as best you can. Try to see, are they approaching some number, or are they not approaching a number, in which case you can just put that DNE. All right, well, I will end this. And like I said, the subsequent videos will have similar concepts, so you'll get a chance to build on this if it's a little confusing. All right, until next time, take care.